Hello, everyone. On behalf of the Data Center World and Vasala teams, we want to wish you a happy Veterans Day and acknowledge all of the veterans on the phone as well as military families. We thank you so much for your service, and we appreciate all that you have done for our country. Today, we will be focusing our webinar on power, AI, security, and the future, the game-changing data center trends for 2026. This is brought to you by Data Center World and sponsored by Vasala. I am Tara Gibbs, Senior Director for Data Center World, and I will be your moderator for today. And let me just run through a few housekeeping items before we begin. The slides will advance automatically throughout the event, so you may also download the slides and other resources from the resources folders available via a widget at the bottom right of your console. You can submit questions to our presenters at any time by typing them into the Q&A window. Additionally, if you are experiencing any technical problems, please type your issue into the Q&A text area, and we will be glad to offer one-on-one assistance. You can also hit F5 or Command R on a Mac, and this will refresh your console. So now on to our presentation. Power, AI, Security, and the Future, the game-changing data center trends for 2026, sponsored by Vasala. The data center industry has never moved faster or grown bigger. 2026 marks a defining year where AI acceleration, power constraints, cybersecurity risks, and sustainability pressures are converging to reshape digital infrastructure on a global scale. Today, we will hear first from Bill Clayman, CEO of Apollo.us, award-winning data center trailblazer and top cloud influencer. Bill brings 20 plus years of experience as a visionary in cloud, data centers, and AI, holding pivotal senior executive roles at Switch Data Centers, EPAM Systems, and MTM Technologies. After Bill's presentation, we'll hear from Luke Kava, and Bill will be introducing Luke at that time. So, Bill, I will pass it off to you, and thanks so much, everyone.
Thank you so much, Tara Gibb. What a lovely introduction. And I want to echo the sentiment of a very happy Veterans Day. And obviously, thank you to all the wonderful people that have contributed their service to this great nation. So as Tara has mentioned, this is going to be a very fun, lively conversation, I promise. I'm also one of those, like, I'm a millennial, so if you're like checking out your Amazon shopping list and you're listening to this kind of a podcast, it's okay. I don't mind. You're not going to offend me. But I will yell at you when you need to come back and see some really cool statistic or a finding or something that's really fascinating. I want to let you know that I love an interactive audience, and so does Luke. I found that out earlier in our conversation. We like to have a conversation and some back and forth. So this is your chance. If you have a question, comment, concern, whatever, I can multitask. I'm actually going to keep an eye on the QA in the chat. So if you have a question or a comment, listen, if it's good, we're going to stop the conversation. We're going to bring it up. Because listen, unless you've been living under a rock, the data center industry is having a moment. We're in the spotlight. For some people, they're enjoying it. For other people, they're quite uncomfortable. So today's conversation is going to revolve around these absolutely wild trends that we're seeing. And I don't want to make it ethereal. We're not going to just go left and right everywhere. It's not going to be a wide net that we're going to cast. We're going to go pretty specific fishing here. But we're going to talk about some of these really interesting game-changing trends. And what I'm going to be sharing with you are some exclusive findings from the AFCOM State of the Data Center Report 2025, was just released earlier this year, and specifically focusing on what's changing, the kinds of tools that you need to sort of make an impact in this data center world that we're experiencing today, and the partners that are required to drive an AI-driven future. As Tara said, I'm Bill Clayman. I'm the co-founder and CEO of Apollo. I'm the executive chair of data center programs here at Informa. I'm very fortunate to get to be a contributing editor of Data Center Knowledge, and also help put on the industry's longest running and biggest conference, which is Data Center World. But before we talk about any of that fun stuff, we're going to dive into this market, because it's insane. It's absolutely wild, right? Everything from these, I feel like nobody's getting out of bed these days unless it's like a gigawatt opportunity, and that's what you're buying a data center on. Is they just give you hundreds of acres and a gigawatt of power, and that's it. And I firmly believe that you need two things to be successful in the industry right now. You need power, and you need bravery. Whole lot of bravery, and we're going to be talking about that just a little bit today. So the data center market is crazy, right? You flip on your favorite news channel and you're hearing about us, right? Whether it's, good or bad. And honestly, our environment, what Luke and I are going to be talking about is at the heart of all of this. We've been having conversations with net new people that are coming into the industry. They've never heard about us. And now all of a sudden they're asking, what is a data center? What are some of the tools that are required to run this thing? And honestly, if you take a look at under the hood, you'll see that there's no stopping this, right? The proverbial dam of ChatGPT has burst open. There's no traversing this thing backwards. And so if you take a look at this market right now, there's a really interesting report from 451. It's part of S&P Global now. There's over 10,000 of these co-location wholesale facilities across some of the major markets. And please understand, it's not like they're not counting the smaller edge facilities, some of those remote points of presences, right? This is sort of a high level count of them. And there are now over 1,000 hyperscale facilities, more 3 times as many as there were about 5 or 6 years ago. None of this is slowing down. All of this is growing. Now, when I said the comment around power, I really wasn't kidding. And we're gonna talk about this just a little bit. If you take a look at the global perspective of the data center industry, that includes every single person on this call. And I saw some really cool corporate names. Some of you are big, some of you are not so big. Look at the amount of megawatts, gigawatts that are being taken down across this entire industry. It's extraordinary. And this is coming from, they call me a geriatric millennial. They don't have to use that word. They could just call me an older millennial. That's fine. But as somebody who came into this industry 20 years ago, working in a 5 or 10 megawatt facility, that was big, man. Those were big facilities. And now 100 megawatts is becoming the average deal size. And obviously we're seeing things that are much, much more. And this global capacity, this energy demand for our industry is only slated to grow. Now that's just the introduction here, right? Because we're going to jump into some really cool data center trends. We're going to go into some new perspectives into how are we actually building these facilities that are required to run AI and ChatGPT and your GPT generated whatever it is you want to use. We're going to talk about some challenges facing our industry. We're going to talk about some really fascinating findings for AI cooling, rack density, and power. That's one of those ones that I'm going to call you back so you can check it out for a bit. And then we're going to hear from Luke at Vaisala, and we're going to talk about some of the things that you need requiring to help support these environmental changes that we're seeing in the industry. So we're going to dive in. So again, these are exclusive findings, which you're not going to see anywhere else. But since you are here on this wonderful Informa AFCOM webinar, you're going to get a chance to preview some of these stats. And by the way, you have to pay attention because at the end, I'll tell you how you can get this report. But look, we're going to give you some of these trends. If you take a look at this market right now, you'll find something just absolutely wild. The average size, friends, the average size of our facility is now more than 30 megawatts, 32 megawatts and growing. This is the first time we actually asked this question. What we've seen is that the number of data centers across all locations that we surveyed is going to more than double over the next 24 to 36 months. So not only are the size of our facilities growing, the amount that we're putting out in this world, they're growing as well. And obviously, I don't need to tell you why, right? We're more connected than ever before, whether it's your smart speaker, your car that can drive itself, or obviously, ChatGPT or your generative AI technologies. These systems, these things that support this level of connectivity are everywhere, and they're only starting to proliferate. And actually, what I'll tell you real quick, we're going to go back to this slide just for a second. We're completely running out of capacity in primary markets. I just want to be clear with you. In Northern Virginia, the vacancy rate, where is it? Right there somewhere. It's northern. Look at this. Look at how much stuff we're taking down. It's less than 1% vacancy. That's like almost nothing. And some of these big tier 1 markets, call them NFL cities, it's 2 to 3%, also barely nothing, which is why, friends, we're seeing net new markets open up, secondary markets becoming primary, tertiary markets become secondary, and all new places are opening up for us to do business and do really, really interesting things with. So how how are we bringing these facilities online? What are we actually using from an architectural perspective? And by the way, we got some questions coming in for the Q&A. Don't be shy. You can pop those in there. You won't distract me, I promise. But what's fascinating within our facilities is that many individuals are starting to take a look at a different way to bring these facilities online. Hybrid approach of traditional and prefabricated modular architecture, very close to traditional brick and mortar approach, right? But there are facilities right now. For example, there's one in Red Oaks, Texas, that is a 400 megawatt facility. There's 10 40 megawatt halls, and each of those 40 megawatt halls, you ready for this, is more than 70% prefabricated, constructed offsite, built, and then delivered on site and then put together to do something extraordinary with it. Again, go and create time to market much, much faster. So these new data center builds, even retrofits and new constructions or brownfield, greenfield type of architectures, are experiencing, you can call it a transformation, you can call it, a change. I really do feel like it's a renaissance actively happening in our industry. And it's not without its growing pains. It's not without, under this shirt is a whole bunch of bumps and bruises, right? The real challenge is impacting our industry. So we know they're getting bigger. We know there's more of these facilities out there. Obviously, you understand why the proliferation of data centers is happening, but underneath the hood, kind of what are the challenges? They're pretty extraordinary. I got to be honest with you, right? So we learned very intimately that there are some pretty significant challenges happening in the space. Obviously, rising costs. We need more people. Scaling to meet this demand of AI and density for power, cooling, and sort of everything in between, ensuring security against evolving cyber threats. That was a big one. Now, what you don't see in this report, well, actually, I'm sorry, you will see in this report, what you don't see in this presentation is that we actually dove in to those cybersecurity concerns and constraints, everything from denial of service attacks to ransomware attacks, to physical and as well as like logical challenges. Physical challenges is a big one, actually. That was, I'm just not going to sugarcoat it. That was the first time we really asked that question: is what are your biggest concerns around physical security? And again, I highly recommend you check out the report if you want to see what those folks responded with. But see, these are some of the biggest challenges that we're seeing in the industry. And here's the thing: these are sometimes showstoppers, right? These are sometimes big elements that increase our time to market from 4, 5, 6 months to year plus 16 months and so on to bring this physical infrastructure online. But what I want everyone to understand, everyone to talk about as we discuss this is this: artificial intelligence, cooling, rack density, and power. This is sort of like the meat of the conversation. And I know Luke's going to get nice and ready, because after this, literally got 4 slides left. We're going to bring in Luke here. Okay. This is one of those things where I'd love for you to get off. Look at these questions that are coming in. So, Dan, great question. Are these tier rated? To be honest with you, we send this report out to tens of thousands of people, and to be honest with you, the responses that we get are everything from small 1, 2, 3, 4, 5 megawatt facility somewhere, in the middle of, North Dakota, all the way to the Googles, Microsofts, hyperscaler. So the technology that you see in there the technology. The results you see in there are actually a culmination, a true industry perspective of some that are smaller. And some of these guys are actually tier 0. Those are the crypto folks. We don't have time to get into that kind of conversation. All the way to the tier 4 plus kind of architecture. So they're everything in between. I love these questions. Andre, you'll know which report this is. I'll tell you at the end of it. You'll get a copy of it. Keep them coming. Keep the questions coming. Luke and I love those. We're going to have some time at the end here to cover this as well. So when we talk about AI, cooling, rack density, and power, I really want to put this into perspective so you understand just where we are in this market. And then again, we're going to pass it off to Luke here in just a second. Folks, if this is a moment for you to get off your Amazon shopping list, this is it. Come hang out with me for a second, because we live in a world that's just discovered oil, but hasn't invented the internal combustion engine, right? All this raw material, and we don't really know what to do with it, right? And just like oil, it's in everything, right? It's in M&Ms, the red ones specifically. It's in food, it's in medicine, it's in my clothing, it's in shoelaces. Where we are right now in this age of AI is, how do we get from a barrel of oil to a shoelace? And not just any shoelace, one that doesn't cost the entire shoe store, and one that can actually tie a shoe for you, right? So that's where we are right now. We also know that there's no going back. There is no going back right now. This type of architecture is extraordinary, and we have now, as human beings, reached a new level of how we interact with data. That's it, right? And humanity's first instinct, whenever we discover anything new, is can we let it on fire, right? There's your joke, right? But the equivalent of that is ChatGPT. But what you and I know is that ChatGPT is not the end-all app. There's so much more, and there are massive, folks, massive impacts, which is why I'm so excited when Luke is going to be coming in to talk about what Vaisala is doing from a tools perspective that are impacting our environments. Guys, do you realize that we're asking infrastructure to do things it was never really ultimately designed to do? These levels of density, water manifolds, new levels of environmental monitoring. These systems are wild, and the impacts that they're having are wild. 80% of our respondents came back with requirements saying that they expect requirements to increase with the introduction of AI workloads. 80%. They're like, we know this is going to change the architecture of our racks. We know that this is going to change what we're doing with this. And honestly, I don't know how ready we are, because here's the kicker. If we look at data center rack density alone, these racks that we've got that support all of this infrastructure, you have to understand something very, very basic. All right. In 1988, this is one of my friends. He currently works for Lambda Labs. He used to be Microsoft. He used to design their Microsoft racks and stuff. In 1988, the average rack density of a rack inside of Microsoft was 1 kilowatt. Isn't that cute? 1 kilowatt per rack. I love it, right? I think it's so neat. Fast forward in the AFCOM State of the Data Center report, we are, drum roll, 16 kilowatts per rack, which is great, right? We've improved. Go team. But here's the kicker, okay? In a standard rack, a single NVIDIA server with 8 H100 cards consumes upwards of 11 kilowatts per rack. So if your average rack density is 16 and the average rack consumption for an AI server is 11, what are you going to do? Put one in there and a whole bunch of blinking panels? That's not going to work, right? So you have to think of what we're going to be doing to support this. Now, friends, I want to show you one very important statistic. Take a look at this graph here on the left, right? If you take a look at true AI readiness, you're really talking at people who are at the 40 kW, 30 to 40 kW range and above. So if we take a look at a snapshot of the market today, friends, only about 19, maybe 15 to 19% are prepared for this AI future. Everybody else is asking, how do I increase density? How do I improve monitoring? How do I actually understand what's running inside of this environment, right? And here's the challenge that we're all experiencing. It's not just rack density. We are going to have a bit of a physics lesson right now, because officially, now this is just to be clear with you, we have reached the limits of how much air can dissipate heat for mechanical equipment. Now, nobody go on LinkedIn and say that Bill Clayman is saying that airflow is going away. I am not saying that, but we are approaching the limits of how hard you can blow on an AI server to cool it. So we have to have, obviously, liquid cooling. 34% of respondents came back and said, we're starting to fail on our cooling capacity because we don't know how to cool all this stuff. And there's a new approach to all of it. And we need to figure out how to actually go at this. And please remember, what we're actually putting inside of these environments has fundamentally changed. Let me put this in perspective. These aren't email servers anymore. Citrix, VMware, Microsoft SQL, fun stuff, right? These $5,000 pizza boxes, that's still there from an infrastructure perspective. But what we're putting in right now are no longer $5,000, Dell servers. They're basically a Lamborghini in a rack, like $450,000 to $500,000. And they are so valuable, and they're running at 100% utilization. You can only imagine something that takes up so much power, so much cooling. You have to look at it differently. You can't just assume that the same environmental monitoring, the same approach, the same air cooling, all of this stuff is going to apply to these, mail virtualization servers versus this high density, high performance compute AI architecture. My one big little thing to everybody listening right now is, you could use any analogy you want, oil, or we've struck gold and all this stuff. find your gold nugget. My ask of everyone here is, as you listen to this energetic dude talk, and when Luke comes in to talk about the actual engineering side of this conversation, ask yourself, in your world, in your environment, how are we managing these systems? Are we ready to adopt this higher density kind of compute, right? Because that's where this world is going. And my big point in working in the data center space and having constructed smaller architectures as well as big ones, very, very big ones, you have to know what's happening at the rack level, behind the rack, in front of the rack, in the environment as well. Because listen, losing an email server or an Exchange server or SQL, shucks, it's gonna be a headache. It'll cost you $5,000. Let's replace a server. Some angry executives. But losing an AI server, that's like 400 grand. That is, I'm going to teach everybody a new acronym. Ready? As if this industry doesn't have enough. Ready? It's called an RGE, a resume generating event. Right, there we go. I can hear the laughter on the opposite side of here. Thank you for that. But that's true, right? So you want to make sure you have environmental aspects in there to make sure that you're compliant and actually working with the environment that you're trying to support, right? And this is the big part that I want everyone to understand, and this is where I'll pass it off to Luke here in just a second. But we're experiencing a trend reversal, right? There's this thing called Javon's paradox, right? Where as efficiency grows, so does consumption, right? It's kind of parallel. For the first time in our industry, consumption is outpacing our efficiency, right? And when you take a look at these metrics, Boston Consulting Group, 100 gigawatts by 2030, 130 gigawatts. I just need to put this in perspective for everybody. 1 gigawatt is for a city of 1 million people. 10 gigawatts is for a city of like Los Angeles or New York. And 100 gigawatts right now is approximately 10% of all the lights that are currently on in the entire world. So when I get these estimates of saying we're going to need 100 gigawatts in the United States, my immediate response is, you expect us to build enough power plants for what, like 10 LAs? 10 New York cities? It is an extraordinary moment. But again, going back to the data center architecture that's actually consuming this, going back to these environments that are drastically changing, sitting alongside traditional architecture are now these AI, HPC environments, is extraordinary, which is why we don't have enough power, which is why we're seeing these environments change and more people are going after on-site power generation. And this is so wild. 62% of our respondents are considering leveraging on-site power to improve data center efficiency resilience, and about 20% have already implemented it. And all of this changes the dynamics, the DNA of the actual facilities that are running these kind of architectures. Now, as I see that there's a bunch of people asking how they can contact me. You can find me on LinkedIn. I'm really easy to find. But if you do want to learn more, I heavily would suggest that you find this report. And if you're an AFCOM member, you get this report as a part of your membership. And if you are not, you can send me a direct message. I can tell you how to get this report as well. Again, I'm easy to find on LinkedIn. So I'm hoping that my LinkedIn inbox is exploding with a lot of new connections and new friends and faces. So you can read more of the findings. Again, remember, this is just a snippet. Now, as I pass it off to Luke, I want everyone to sort of take a moment here, take a deep breath, which I know I should be doing as well. But understand that my goal for each and every single one of you is to find a gold nugget here, take it away, and understand that, just simply put, these environments that we grew up in, that you and I grew up in, they're changing, and there's no going back. And for you to support high density, high performance compute, you must look at the underlying architecture, the environmental aspects of it. What am I monitoring? How do I become more efficient? Because the systems are more valuable, the connections are more valuable, and understand that the actual infrastructure is changing as well. So I'm super excited. I had a chance to speak with Luke here in the pre-call. Sometimes I wish our pre-calls were like recorded because they're so much fun. But Luke is a sales engineer, an application sales engineer at Vaisala, and he supports customers across the United States and Canada, so North America. He's got many years of experience focused on industrial instrumentation. Luke does an amazing job collaborating with engineering firms, the people who actually build this stuff, contractors, building designers, and he ensures that each project requirements are met with precision. And again, focusing on the environmental aspects of bringing a facility online. He is a mechanical engineer by trade, that's which is a bachelor's degree from the University of New Hampshire, and his expertise is literally what we talked about earlier: HVAC, data centers, really cool life sciences applications that he helps really all sorts of organizations create more reliable and measurable solutions, which is, again, why I'm excited to have him on board, and why he's actually going to take a moment and talk about the tools, the real stuff that I just discussed, a lot, that are making a change in the data center industry. So I'm gonna stop talking. And again, keep those questions coming. I didn't even get a chance to get to ask all of them. There's a bunch on here from Dan. I see one from Raja. Don't stop. Keep those coming. We'll get to those at the very end. But before we get to that, Luke, tell us about the cool stuff that you're working on, man.
Bill, thank you very much. I will do my best to match the energy here. I don't know if that's necessarily possible, but thank you. And thank you everyone for tuning in today. Again, my name is Luke. I'm an application engineer with Vizsla. And today I want to go over in a little bit more detail some of the things that Bill discussed, but with a specific focus on the importance of environmental monitoring, as well as the importance of high quality instrumentation and its direct relation to how data centers can operate more efficiently and hopefully save some money and expand the industry even further. So just a little background first on Vizsla and what we do. So Vizsla is a measurement and sensor company. So we were founded nearly 100 years ago, primarily as a weather company, focusing on weather instrumentation designed for help with forecasting as well as environmental monitoring of the outdoors. So over the years, we've tweaked these technologies to transition into more industrial measurements, and we've diversified our offering of instrumentation to expand into many different industries, one of our largest ones now being data centers with the growth that we've seen. So here on the screen, I've highlighted some of the parameters that we have solutions for. However, I will make note that our flagship business was built off of our humidity measurement. So today we're going to focus mainly on humidity and temperature, which is this cornerstone that Bill kind of painted for environmental monitoring within these data halls near these racks to optimize your power usage as well as your efficiency of those cooling systems that we see. So jumping into some of the trend highlights we've seen over the past few years and then what we expect over the next several years. So of course, no secret to anyone, we have artificial intelligence and machine learning and the infrastructures that are being built out to support this production. They're only growing and they're growing at an extremely fast rate. I think Bill brought this up earlier, but I think fast and quick is going to be a very recurring theme through my few slides that I have here. So everything is changing very rapidly. And as this progression happens, we have different workload needs. So like Bill said, the environment's changing. What we have known these past years is changing. So we have to be able to adapt to that. And I think what often gets overlooked and what we don't see is that on the flip side of all this computing power, we have this increase in heat production and we need increases in cooling capacity to compensate there. So secondly, we have what Bill had mentioned, rack density increasing. This power density is driving these new technical requirements. And with that, we have the transition from these fully air-cooled sites to now liquid cooling, hybrid cooling, and everything is happening where you're building out, you're retrofitting, and then you're even building new systems. So now more than ever, we're hearing things like power usage efficiency, water usage efficiency. All of these things are going to be pertinent to exponential growth and being able to sustain that growth over time. So of course, this is data center focused, but my expertise lies in monitoring instrumentation. So I've seen in my years of experience in data centers is that monitoring instrumentation is often overlooked as a piece of this puzzle that needs to progress along with everything else among these infrastructures. So systems that are too slow to deploy or too complicated to implement are likely and are being left behind. So like Bill had mentioned, I believe the statistic was 70% is being deployed as prefabricated deployment. So that's speeding up your time of deployment. And if your instrumentation cannot keep up with these retrofits, so they have the ability to be modular and changed over time, they need to be changed so they can keep up with the development that we're seeing at the same rate that we're seeing. And then lastly, we have this increase in focus on energy efficiency and sustainability. So when we talk about sustainability, it's in everything we see. So it's not just in data centers, but everything we want to do, we want it to be efficient, we want it to be sustainable. So another word I like to bring up is innovation. So a lot of times in data center industry, the innovations referred to as advancements in technology or better technology. What can we do now that we couldn't do last year? But I would challenge that to say innovation just isn't about better technology. It takes all those smaller, minute details where it's ease of installation. It's what I mentioned. It's speed of installation. It's less maintenance, less man hours of people on site replacing things that should have never been used in the first place. So it leads to better operations and more sustainable operations overall. So I actually stole this graph from Bill's slides earlier, so hopefully you recognize it if you were paying attention. But I want to highlight a few of the primary challenges in data center operations that were discussed. So the top three that I found here that are going to relate directly to what I want to talk about are this first one, rising operational costs in energy and cooling. Unfortunately, we can't address the talent shortages, but we can address scaling up to meet those increasing power and cooling demands. And then lastly, managing high performance workloads down at the bottom. So that's your artificial intelligence, that's your large language models, things like that. So this, I would raise the question of, is cooling capacity a limiting factor to data center growth within the industry? And is it due to lack of visibility? Is it due to bad measurements? We don't really know. So I guess that leads to the one question of how can higher quality or high quality instruments in general provide a solution to combating these challenges? So here I've put together this slide. So this shows the difference of low accuracy sensors and high accuracy sensors and how they would control a cooling system. So in orange, we have that low accuracy line, and then in that greenish blue, we have the high accuracy line. So if you're using low accuracy sensors, there's going to be a higher possibility for a larger deviation from the actual temperature in the space. So really all that means is that the sensor, what the temperature that the sensor is reporting is not very close to what is actually happening in the space. And what happens there is that these sensors were placed to be the controls, to be the eyes and the ears in these halls to control these cooling systems. So if the data being reported is incorrect, you end up with resources wasted, you have increased overhead costs for running these systems at unnecessary times, and then you also have a higher potential for system failure. So getting into the more specifics, I put a few bullet points here. So say we have falsely high temperature readings. So this graph's in Celsius, we can work in Celsius. Say for hypothetical reasons, we control to 25 degrees Celsius. However, we have falsely high temperature readings. So we have an actual temperature at 25, but all of our sensors are reading 30 degrees. That's going to write back to our cooling system. It's going to say, hey, time to turn on. We need to cool 5 degrees. So that whole system is going to ramp up. It's going to cool the space. It'll stop probably roughly 5 degrees, depending on what your sensor's reading. And then that whole space maybe drop from 25 down to 20-ish. So 20-ish degrees Celsius. So that was entirely unnecessary, and that was a waste of energy. So on the flip side of that, we have falsely low temperature readings. So say our temperature in our space is actually 30 degrees Celsius, but it's reading at 25. So it's these sensors are writing back. They're saying, hey, we're good to go. We don't need to kick on right now. And as that temperature begins to rise, you eventually need these sensors to send back a signal to the cooling system that says, hey, we're overheating. There's going to be a risk, and this IT software isn't rated for these conditions. So you're risking that downtime if your sensors are not reporting accurately. So lastly, I just want to highlight this one bullet point at the bottom that I brought up. So this is in relation to humidity specifically, not temperature. So humidity is maybe lesser known than temperature, but when you operate with IT equipment and electronics, it's also a very important parameter to monitor because you can't be too dry and you can't be too moist. So if you're too dry, you run the risk of electrostatic risk that's going to cause data corruption. And then if you're too moist, you run the risk of your temperature fluctuating, and then you end up with liquid condensation forming in these racks. So you're going to have electrical shortages, and then you're going to have downtime there. So none of these things are good. So we try to control to that 40 to 60% relative humidity sweet spot. So this was all hypothetical. We played a hypothetical, but as we deal with the facts, we have a recent report put out by industry data from Standard Calibrations that reports that 25% of these sensors fail, and they report outside of their specified accuracy. So, for example, that's 1 in 4 sensors. On the smaller data centers, maybe in previous years, maybe there's 100 couple hundred sensors. Now on these hyperscalers, there are thousands of these sensors. And if you want to tell me that 25% are reporting outside of their specified accuracy, that is a lot of bad data that is being taken in that should be compensated in a way that it's not. So if your whole cooling system is operating off of relatively arbitrary values, you just saw that that whole system is going to be cycling on and cycling off at times where maybe it doesn't need to be, or maybe it definitely needs to be if you're going to risk that downtime. So moving to an actual case study that went on. So this case study was conducted by a leading climate system provider in the data center industry. So if you want more detail, I'm just going to go over the quick facts here. But what they did was they took 3 different cases at 3 different locations, and this uses a baseline of 1 megawatt of IT equipment. So smaller than pretty much anything we'll see today, but we will extrapolate towards the end when we see the monetary effects of how this change happens. So the case 1 in that bluish green on the left side of the graph, that is your control. So that's a standard 11-degree temperature delta between your return air and your supply air. Case 2 is the same delta, so still 11 degrees Celsius. However, the supply and return were both reduced by 1 degree. So still 11, but your return air is coming back 1 degree cooler, and it's cooling 1 degree lower. And then case 3 is really what we want to focus on. So that's when you cool an extra degree, and you have that extra degree within your delta temperature from supply to return. So now you're at a 12-degree delta. So let's look at case 2. Not too concerning. We have, say, a 2% annual energy usage uptick in Frankfurt, but less than 1% in the other locations. So not super concerning. But when we look at case 3, we're up over 8% annual energy usage. And a reminder, this is just for 1 megawatt of IT equipment. So that correlates over on the right to monetary values we've extrapolated. So that's 8.5% correlates to 60 kilowatt hours per 1 megawatt IT load per year. So now you look at 10 megawatts, that's 600 kilowatt hours. You're looking at 400,000 euros in energy cost over 10 years. I apologize, I did not convert this into USD, but hopefully this conveys my point in a more effective way, because that number would only be higher if I had converted it to USD. So let's look at something maybe more relevant to today's data sizes. At 100 megawatt IT load over the next 10 years, you're looking at over 4 million euros in energy cost wasted just because you're overcooling by 1 degree. So this is my last slide, so we'll get over to the Q&A, but I wanted to just highlight what I just covered here in the last few slides, and maybe the importance of some of the things that Bill covered as well. But there is a real need for high quality measurement, and it will have a direct effect on the money that goes into data centers, as well as how sustainable they can be long term. So I've broken this down into 4 main pieces, and I'll just go over them right in order. So first, we have accuracy. Accuracy of your sensors is going to be the meaning of getting the true value of your data. So that means that the data you're getting back from your sensors, we know that it's going to be as close as possible to the actual value in the space that you're looking to control. This leads to peace of mind. You know your operating efficiency. This brings down your PUE, it brings down your WUE, and everyone's happy. However, when we discuss stability, stability is related to accuracy, but it's kind of like a parallel. So stability results in accuracy long term. If you have stable instrumentation, you have very accurate over long term. So if you're accurate, but every 3 months your measurements are drifting and you can't trust them anymore and they need to be serviced, you're going to be wasting man hours, you're going to be wasting time, you're going to be replacing sensors. So that's all going to be additional cost. So we need stability within our instrumentation. And then lifetime value. So I like to look at this as large investments are always a bit scary, but things like data centers are very large investments. So it's important to not just look at the cost as the number on the price tag when you make that initial purchase, but more as the value and what the value added is through efficient operation and the money you're saving through efficient operation for all of those things that I mentioned just before with stability. So you don't have maintenance techs on site all the time. You're not replacing these sensors every 3 months or every 6 months. maybe you look at them every 2 years or every 5 years, and you check them and you go, oh, okay, they're still rating good. I know I'm still operating efficiency. There is extreme lifetime value there to high instrumentation. And then lastly, I just wanted to touch on sustainability again. So of course, like I mentioned, sustainability is in everything, but is absolutely very important in the data center world. So we have topics like advanced cooling, waste heat recovery, renewable energy, everything that I mentioned, PUE, WUE, everything is being talked about when people are in the boardroom. They're saying, hey, can we build another site? Can we build another location? Can we keep continuing to grow at this rate with the size of the carbon footprint that we're placing? Is this logical? Does it make sense for us to pay our employees at this rate that we keep going? So things need to be sustainable, and you can't do that without high quality measurements. So hopefully I was able to convey that point to you guys, that high quality instrumentation is very important. But thank you again, and let's move on to the Q&A.
Luke, that was very, very informative, and thank you. I was actually taking like notes as you were talking. I think one of my favorite slides was the measurement accuracy, how it affects data center operation. Which I guess the good news is that we've got a question that kind of focuses on that right now. And by the way, we got let's see, we got 18 minutes plus or minus, right? Then I have to give it back to the moderator to give us some final closing words. But this is a chance for you to ask some questions, so don't be shy. Ask those away. Luke, I'm going to ask you this first one, and we had a very interactive audience. In case you didn't notice, we got a bunch of people posting in the Q&A, which I love. Go team! In your slide, one of the slides that you talked about was how measurement accuracy affects data center operations. You had a little nice graph in there and chart. So Omar asked a really interesting question. What thresholds should operators strive for in 2026? And what I'd love for you to do for me here, Luke, is let's take a look at this from a new lens, right? In terms of understanding data center architecture, let's call it, you don't have to look that far back, like 4 years ago, right? And like fast forward to today with these new types of architectural designs that we have, density, all of it, right? So in terms of looking at that lens and understanding how measuring the environmental aspects and how much more important accuracy is today, what's your suggestion for the folks that are on this call and for data center leaders in general, as far as like what thresholds, what new variables should they be looking at in terms of designing their architecture for environmental monitoring and support?
I mean, that's a really good question. So it comes down to the specifics of the data center you're working in, and also I will note that location is a big thing. So if you're located down in Phoenix in a really dry climate and you don't have a lot of moisture to remove from the air, you may have less power usage, but you gotta reroute that power usage towards cooling systems because it's so hot. But you're not worried about taking that moisture out of the air. So these types of parameters, we work with a lot of different engineering firms that are specializing in data center design and functionality. So they want to operate at the most efficient means possible. So in order to do that, you're using these high accuracy sensors that are either plus or minus 1% or less in terms of relative humidity. And then it's really like 0.1 degree Celsius in terms of where you want your temperature accuracy to be. Because like I showed there, I mean, if you're off by 1 degree, these data centers are meant to operate for years and years on end. And if that's the sensor in place, you're going to be wasting a lot of money if you are functioning with, I guess, a low accuracy sensor that's reporting even 1 degree off.
Especially if it's like AI gear, right? And Luke, it's just like, especially if you're looking at like this more high density, more valuable gear. Can we stick with that 1 degree of overcooling? Again, you and I, and pretty much everybody on this call, right? When I worked at this really neat place, it's called Worldwide Fittings. It was they made these guys. Look, I actually have an example. Little pipe fittings. I have one. I'm so proud of it. I actually think I made this one because my boss made me sit down in front of a CNC and a lathe. He's like, Bill, if you want to know how to be the technology person for my business, you got to put this stuff together, which I appreciated. And in that kind of environment, we saw, how this traditional type of architecture was, basic stuff, right? Fast forward to today, where quite a bit of that is changing, right? So I wanna stay on that 1 degree of overcooling here, and how much 1 degree is overcooling with like a traditional email server versus like an NVIDIA DGX or AGX, and these really high density pieces of equipment that you could just really start to blow your budget out of the water when it's not running efficiently. So Brooke had a really interesting thought here. So thoughts on power requirements, i.e. 800 volt DC for mechanical equipment, fans, etc. I just got back from the Vertiv Innovation Fair, Vertiv Technology Fair, excuse me. And, I had a chance to sit there and kind of listen to some of the things they were designing. But back at Data Center World, we had a keynote speaker, Wade Vincent. He came up and he said, I hope you're ready for the megawatt class era of racks. And I'm sitting there, I'm like, you serious? You're going to bring a 1 megawatt of power into one rack? And so that in itself is wild. That in itself is just absolutely wild, given that you're talking about an industry average of 16 kilowatts per rack. Now you want to put in, 1,000 kilowatts. It's just wild. But in that sense, right, as we sort of look at these new sort of power conversations over at Vertiv, and honestly, Schneider Electric and a couple of the other vendors, they're now starting to talk about bringing a DC, direct current, into the actual data centers to change the power paradigm to support these high density racks. Luke, I'm really curious, in your world, the sensors that you deploy and deliver, the data centers that you work with, it's a pretty noticeable step change in innovation and accelerating the value of environmental monitoring and sensors. Talk to me about the power equation, right? In terms of seeing what's going in the rack, how much more important it is to actually know if you're overcooling and what you're doing within these racks. And really, just from a density perspective, help educate us, like, Bill, here's the big difference between a 10 kW rack and one that's like 300.
Yeah, and I want to stick on that power requirement that you had just mentioned there. So one thing that we're seeing that's becoming more common, and we try and push as much as we can, is the old, I mean, in instrumentation, I'm sure some people are familiar, you have analog signals and you have digital signals. So the old way of moving is everything's analog. You're sending a 4 to 20 current back to your control system, your air handler turns on, and that's how it works. That uses a lot more power than these digital signals. So we have things like BACnet, like Modbus, that can operate at extremely fast levels and extremely low powers. So what you're able to do with these digital signals is you can power 10, 20, 30 different sensors with one power supply that would previously be used for, you'd have one power supply for everything. So you're chaining these together. They're each getting their own digital signal, their own address, and they're writing back to the same controller. And because they're addressed, you can differentiate them. So you can say, okay, here at the end of the rack, it's really high temperature. So I need to open that vent. But here at this end of the rack, this is good. We don't need to open any vents over here. So that sort of modularity that we can do and that instrumentation can do allows for you to see those smaller racks and those bigger racks where it's not out of the question to have a 1 megawatt rack. Like it's going to happen at some point, and you really need to be ready for it. Because like I said, instrumentation and monitoring instrumentation and the infrastructure, it's often left out of the conversation because everyone is so focused on the AI, the chip technology, and what that can create, because that's what's exciting. I mean, the instrumentation is not necessarily what's going to, I don't know, come up with your recipe for dinner based off of the picture of your fridge and what the ingredients are. So
I love it. And they do have cameras like that already inside of the fridge to tell you exactly what exactly what you should be making your lunch or dinner with. I think that's a really neat piece of technology. And also my refrigerator will tell me, Bill, stop snacking at 11 o'clock at night, champ, right? Save these ingredients for breakfast for tomorrow. I want to say thank you to the audience here. You are being very, very interactive, and I love the questions that are coming in here. I've got one from Daniel here. Luke, let's opine on this one a little bit here. You talked a lot about, we discussed the primary challenges, and yes, I was paying attention. Thank you for borrowing that slide. I think it was very, very appropriate. In your talk, right, you talked about reliable instrumentation. Let me be honest, right? I've grown up in this space, and where environmental monitoring has always been important, I really, really believe it's a necessity at this point, right? And some of the things that, so for example, we work on at Apollo is taking that data, for example, and doing some extraordinary things with generative AI to do some wild predictive sort of analysis and accuracy in terms of the data that we see out there, which is again what you're doing with the kinds of technologies you're putting into these facilities. So let's talk about accuracy and stability. Obviously, sustainability is important and the lifetime value. But Daniel asked the question: do you expect a massive growth in the data center space and then a temporary overbuild due to energy deficiencies, as the current grid will potentially not be able to handle the capacity? I want to frame this question, Luke, in terms of what we've been talking about here today. How do you use these types of types of sensors and environmental monitoring controls to potentially not overbuild, right? To create an environment that is a lot more effective, where it allows you to fill those buckets that you potentially have right now, and how these sensors basically give you a better purview in what you have and what you can ultimately support.
That's a good question. And an interesting way to look at it, because I was looking at it more from probably the way that Dan asked it, but we can take a look at it this way. So I would say it's interesting. So say you have a whole building, it's outfitted with all the best sensors, and you're looking to expand. But you're finding that every 3 days, every week, there's this spike in the middle of the day because it's 3 p.m. and it's the middle of summer, and you're finding that everything's operating great, but your cooling efficiency is going way down because you're finding that you're controlling to that 25 degrees Celsius that I had mentioned earlier, but your temperature's starting to climb. It's 26, it's 27. So you're looking at that and you're using that data, because you can log this data, you can timestamp it, whatever you want to do with it, and you can have that. So when you're actually looking to expand and you're saying, oh, that's great, all of our systems are modular, we can retrofit, we can add on to these chains, that's great. But in your data, you're looking at, okay, I don't know if our cooling capacity can support this in the middle of summer. Like this is our weak spot of our design per se. So that's when you look at systems and you're looking at maybe overbuilding, but that's a limiting factor if you have all of this good information, because you say, okay, if I do want to build, maybe my limitation is my air handlers, maybe it's my chillers, my cooling systems, things like that are much bigger players in the HVAC system as a whole. Whereas instrumentation is small, it's what's allowing you to get that data and use it to your benefits, so overbuilding doesn't happen.
I love that, and thank you so much. We actually have time for a couple more questions. We got a couple more that are coming in. You know what? Listen, you're right, Luca. Let's answer Daniel's question. It was great. We could actually just go to the last sentence here. Our current grid can't handle the capacity. We haven't had a modernization of the grid here in the United States since like the 1960s, right? When we operate in islands and silos, which is why if you go back to one of my slides, what was the statistic that I talked about? 62% of our respondents are coming back and they're going to be doing on-site power generation, which, going back to a statement from Candace, who's more of a very nice long comment she's got in there, how they're looking at natural LNG, liquid natural gas, and all these other types of solutions to power these kinds of architectures, right? And I think that's fascinating, because it's changing, right? And it's great, right? I'm an agent of change. I kind of like, when things are moving and ebbing and flow. And so, to your point, it's important not to overbuild, but I also understand trying to build out for capacity, which is why we're seeing these gigawatt types of takedowns. Luke, we've got another really good question here. Omar is asking, do you think AI-heavy workloads will push more operators towards purpose-built campuses, or will retrofits of existing facilities still make sense in 2026? I have an opinion on that, but Omar, I'm sorry, Luke, what do you think?
Yeah, I definitely think that's an option. I mean, I would say one of the most common retrofits that we're seeing, I think maybe it's still a year or two out, is that a lot of air-cooled systems are being retrofit to be liquid-cooled with direct-to-chip cooling. So if that's possible, you now have a new infrastructure where it's already in place, designed for, like you mentioned, email servers, much smaller capacities, but now it can support these AI workloads because you were able to use direct-to-chip cooling on your facility as it was, and maybe not change everything about it.
That makes a lot of sense. So we at Apollo, we have about 4,000 to 5,000 GPUs under our management, and we didn't actually build any new facilities. We worked with existing architectures, and one of those facilities is out in Omaha, Nebraska, Scott Data Center, actually. And they went from a traditional colo HPC kind of environment, 10, 15, 20 kW per rack, to now supporting 70 kW per rack with rear door heat exchangers. And that was a really brilliant retrofit, man. It worked out great. We had available capacity to use, and boom, time to market shortened, able to go and support an AI workload. So I think it's great. Listen, if you want to go to market faster, find available capacity. Make sure that they can deploy these kinds of AI systems and actually do something special with that. So we've got time, maybe for one or two more questions. I'm trying to see what are good ones here. And you talked about this briefly, right? As far as like what types of cooling environments are most robust and taking the most energy in an era of AI and this new type of approach that we must look at. Luke, where should we be placing these sensors? Is it different than what like I grew up with? Does the installation location matter? Help me maybe gain some sense of what a rack looks like and where you should be putting these things.
Yeah. So it's always a good question, and I get it in many different industries, not just data centers, but it's where am I going to place this to have it be the most useful? And it's a tricky question because a lot of these sensors, they can really only measure the air around it. So that becomes the importance of good airflow. That becomes the importance of having an HVAC system that pulls in a lot of outdoor air, and you want that air constantly circulating, so you're not getting these hot spots or these cold spots, because where those servers are, they're going to have fans blowing over them. That's going to be a really hot spot. So of course you want measurement there, but you also need measurement in the rest of the space. So it's tricky. I mean, and that's what these design engineers are paid to do. I mean, they design these systems so you have maybe a sensor every 10 feet down the whole aisle. And then that gives them the ability to say, okay, like I mentioned before, this side of the aisle is hot, this side of the aisle is cold, because you have that versatility and that modularity that we've been discussing this whole time. So it really depends. You really want to place your sensors in an ideal location where you understand exactly what sort of data you're getting, and use it in a way that's going to be useful for your controls as a whole.
That would make a lot of sense, right? Understand your infrastructure, know how and where to deploy. It's a very pragmatic approach here. I love that there's more comments and thoughts. I want to acknowledge Candace's statement around liquid natural gas as a substitute for Freon. I think it's a really interesting conversation that we don't have enough time to get into. And again, Daniel, I completely understand the challenges of trying to build some of these facilities in a geopolitical environment, right? It's not the United States, and building this stuff in Myanmar, for example, is going to be fundamentally different. I got to be honest. We're out of time. We're out of time. We didn't even get to all of these wonderful questions that came in. We will try. If we didn't get to your question or comment, we're going to see if we can try and take it offline. Please find Luke Kava on the LinkedIns. Find myself on the LinkedIns. I appreciate all of the notes that I've already received. In parallel, I won't yell at you. It's okay. You're making good connections and industry connections. I appreciate you a million. So send me a note if you want the report. Happy to contribute that to you. But now, for some final closing words and to wrap it up for us, I'm going to pass it back to Tara.
Thank you, Bill. Thank you, Luke. That was just a fantastic dialogue, and I'm so glad that we were able to involve the audience so much and get to so many questions. So nice work leaving time for such an engaging discussion. Thank you both for your time, and within the next 24 hours, attendees will receive a personalized follow-up email with details and a link to today's webinar on demand. This session is copyright 2025 by Informa, and the presentation materials are owned by or copyrighted by Data Center World, and the individual speakers are solely responsible for their content and their opinions. So on behalf of our speakers, I'm Tara Gibb. Thank you so much for your time, and enjoy the rest of your day, everyone. Thank you.